12.4, similarity of right triangles. So this is the version that you have. Please fill in the blanks. Okay. Considering the proportion, right here guys, ax equal to x over b, where two of the numbers in the proportionals are the same. The number x is the geometric mean of a and b, and the geometric mean of the two positive numbers is positive square root of their product. So the geometric mean of a and b is a positive product such that x is square root of ab, or x squared is ab, right? So another way to write this is that when you say x is a geometric mean of a and b, there are three ways. The first one is this: a over x equal to x over b, where the x is over here. And then if you cross multiply that, that's the version that we have over here, which gives you x squared is equal to ab. And then if you square root both sides, we're assuming to be positive, it will be a and b, because the distance x, because x is the distance, we want to keep the positive value. Okay, so in that particular case, with a small example here, guys, we're trying to show that the x is the geometric mean of the two numbers 5 and 20. If that's the case, you could use any one of these three, but I would actually prefer to just do it this way. Just get in the habit of doing that, guys, which is 100. X therefore is 10. Okay. In this particular case, we haven't said anything, have we? No. So this is fine. Okay. If this is a strictly math question without the context of the distance, you should have a plus or minus. But we're talking about a distance here, guys, so you should just have positive only. Okay. All right. Next page. So we're going to be proving a geometric mean theorem. Okay. So in this particular case, we're going to have to sort of look at this problem kind of in a certain way. Okay, so here we go. You might as well spend some time copying this down, guys. According to this, let me zoom down a little bit. There you go. The first part of the theorem says the length of the altitude to the hypotenuse of the right triangle is geometric mean of the length of the segment of the hypotenuse. And then the second one says the length of a leg of the right triangle is a geometric mean of the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Okay. Let's figure that out. But me personally, I have an easier time if I do not just memorize this, but try to figure this out over here, guys. So I might have alluded to this in class before. When you have a right triangle, we have talked about how the acute angles, this one, and let's call that star, dot and a star, has to be complementary, because these are the two acute triangles of a right triangle are complementary. Now, if this right here is 90 degrees, then these two has to be complementary. Therefore, I'm going to put a star over here. And because that is a right triangle, this too has to be complementary, so that has to be a dot. What you would notice here, guys, is that you created a dot star right angle. Dot star right angle. For the big triangle, dot star right angle. So all these three triangles are, in fact, congruent. So let's see what happens. So what happens is, let's try dot and a star. Dot and a star of this triangle, guys. Then side opposite the dot is h. Side opposite the star is x. If you get this triangle over here, guys, what do we end up with? Side opposite dot is the y, and side opposite the star is h. So when you cross multiply, that implies that the h squared is xy, or we simply say that the height of this is a geometric mean of the 2 right here, guys. Do you see that? Right. So that's what they were talking about right here. So in this particular case, we're doing dot over star that yielded h over x equal to y over h, and that yielded h squared is xy, or simply h is equal to square root of xy. So in that particular case, for this one, the relationship we have is this squared is a product of these two. Okay, hopefully that visual will help you guys. For the next one, the next useful shape comes across when you compare this to this with this to the whole thing. And let's see what that is in a second. In this particular case, this side is opposite of that is a star, and this is opposite of the right triangle, right angle. So if you look at this triangle right here, guys, the small triangle, what we end up with opposite of the star is x, opposite of the right is a, and what we do is we go with the big triangle. The star is, as it turns out to be, a, and then opposite of the right angle for the big triangle is x plus y. So what we end up with is a squared is x times x plus y, right? So this squared is this times this. What's interesting is that this also works for the other triangle. How about this over here, guys? This time, let's go with a dot over the right triangle with this triangle. What we'll end up getting in this particular case is we will find out that this to this, as it turns out, is same as this to the whole thing, right? Let's take a look. So dot, opposite of the dot here is y, opposite of the right triangle here is a b. But if you look at the big triangle here, guys, what ends up happening is opposite of the dot over here is a b. With the big triangle, the right triangle is x plus y. So when you cross multiply over here, the b squared is equal to y times x plus y. So as it turns out, this squared is a product of y times the whole length. Y'all see that? All right. So what we end up getting in this particular case, this one is talking about these two. So we know that a squared is equal to x times x plus y, and the b squared is y times x plus y. Once again, this squared is product of that portion of the hypotenuse times the large hypotenuse. And then b squared over here is a small segment right there of the big, on the same side of the triangle of the hypotenuse times the entire length. So you might want to sort of learn the visual over here, guys. Okay, so that took a little while. Let's do an example here, shall we? Let's keep this up there so we can see what's going on. It says find x, y, z. Got x, y, and z. Okay, how do I do this? Well, earlier we learned that this squared is product of this times this, right? So 65 squared is equal to 25 times 25 plus x. So that gives you, let's divide both sides by 25. So that's 65 times 65 divided by 25 is 25 plus x. And this one, as it turns out, that's 5 and 5, 13, it's 169. Sorry, that's actually just 25. So x turns out to be 144. Now, once we know the x to be 144, we could probably figure out the y squared, right? Okay. So y squared is the product of this times this. If I square root both sides, square root of 25 is 5, square root of 144 is 12, and therefore y is equal to 60. Okay, how do I figure out the z? Well, z, just like this one, z squared, we know, is this times the whole length, isn't it? 144 times 144 plus 25, so that's 144 times 169. If I square root both sides, so square root of 144 is 12, square root of 169 is 13. When you multiply those two out, we end up with z is equal to 156. So there you go, guys. All right, looking at the next example over here, what is c over a equal to? Well, that relationship we know is this to this is same as this to the whole thing, right? So that's a c plus d. Okay, so this is sort of like memorizing these equations over here. So please commit this to your memory. So you have 3 questions in your turn. Pause the video and play it again when you're done to check the correct answer. Welcome back. For number 6 and 7, we're looking for geometric mean of the two number, which is the square root of the product. And 6 times 24 is 144. Square root of that is 12. In this case, square root of 5 times 12 is 60. And what we want to do is figure out what perfect square divides 60. In this case over here, it was just 12 squared. In this case, it was 4 times 6, and that pops out as a 2. And that's 4 times 15, and 15 stays put. All right, in this particular question, they're asking you to solve for x, which we know is that square is a product of the two parts of the big hypotenuse, right? So x is root 35. So if you're looking for y, once again, that squared is this times the whole thing. So y squared is equal to 5 times this, which is 5 times 12. And we just did that here, didn't we? Right. So y is equal to square root of 5 times 12. I'm going to put dot, dot, dot. Make sure you show the step in the middle. Therefore, y is 2 square root of 15. And once again, for z, similarly, that squared is this times the whole thing, which is 7 times 5 plus 7, 7 times 12. And we square root both sides. And we know that that is equal to 4 times 3, right? Which means 4 pops out as a 2. We multiply the rest, 21. So that's the answer for this one. So x is root 35, y is 2 root 15, and z is 2 root 21.